Well, hi, guys. Hey, so in this lesson, we are going to learn standard, or otherwise known as copper, cables. All right, let's get started. There's a lot to learn. All right, so these days, copper twisted pair cable environments are widely used as Ethernet transport. Now, generally in home or corporate networks, the connection between a computer and a switch, or more broadly, between any two devices that need an Ethernet connection, is made using a copper Ethernet cable. All right, so that's the stuff you know. But the most important factor when you use copper Ethernet cable is the distance. Well, there's also cost. But the longest distance determined for a healthy data exchange over copper Ethernet is 100 meters. You got to step up to fiber optic as a transport media when you're going to try to reach distances exceeding 100 meters. Now, while only one pair or two separate wires of this cable is sufficient for analog telephone lines, for instance, used in the past, two pair or four separate wires are combined into a cable that's used in the Ethernet transport environment. One pair of these is used to transmit data, the other pair is used to receive data. So why four pairs and eight wires? All right, well, copper Ethernet cable consists of four cable pairs in total, right? So that's 8 copper wires. We just mentioned that two pairs of wires are enough for data transmission. So why use four pairs of wires? Well, in fact, had we invented this cable, maybe we would have produced it with a total of 4 copper cables, just in case two pairs of cables are used to avoid waste. But engineers thought that the remaining 2 pairs could be used in the future, so they designed a 4-pair Ethernet cable consisting of 8 copper wires. But as a matter of fact, we see that these pairs are also used to transfer energy to the opposite device in power transmission, or PoE, applications over certain Ethernet cables used today. However, we could probably say that these pairs are really not used that much in general applications, and yeah, some of us are kind of waiting for what that future use will be. But if you ask which cables that we're using, copper cables numbered 1, 2, 3, and 6 are used in Ethernet cable consisting of 8 copper cables. So that means 1 and 2 are used for transmitting and 3 and 6 for receiving data. So why a twisted pair? Remember earlier we mentioned that the transfer of data from one point to another is done at the bit level, the physical layer, and that is ones and zeros coded over a copper cable will be transmitted across an electric current, right? When you transmit an electric current through a copper cable, a magnetic field begins to form around the copper cable. That's just physics, right? If you bring in multiple copper cables and they're paired up side by side in the same jacket, well, this magnetic field effect on one copper cable starts to affect and then distort the signal passing over all the other copper cables that are going along with it in parallel. That's typically called a crosstalk effect. So in order to minimize this magnetic field in that Ethernet cable, genius engineers discovered twisted pair. In other words, they discovered that the crosstalk effect is minimized when copper pairs that provide data transmission are wrapped around each other in a twisted way. So what's up with 100 meters? Now, we all know that when electric current passes through a copper wire, resistance occurs on that wire, right? And the transmitted signal, in turn, will weaken in direct proportion to that distance. And in addition, you remember the magnetic effect that we just talked about? Well, that can also be caused within the external environment as well. So it has been determined that the signal transmitted over copper Ethernet cable can reach safely a distance of just over 100 meters. And these are certified measurements depending on the cable type. So the trouble-free working distance has indeed been determined and certified to be 100 meters. End of story. Now, today, it's possible to carry data well over 100 meters with some cables, depending on the environment, but not guaranteed by the manufacturers. Don't try it at home. Or maybe try it if you're experimenting, but it may or may not work. Your mileage may vary. Anyway, what's the arrangement of the cable and how does it lay out? Well, cable layout is very important when preparing an Ethernet cable. So you can't just run cable randomly and expect it to work. You got to use a way that's going to minimize the magnetic effect and comply with the standards. So cables are actually colored for tracking purposes, and the standard colors are orange and white, orange, green, white, green, blue, white, blue, brown, white, brown. I'm glad you asked because there are actually two main standards in cable preparation when it comes time for termination. All right, so one of them is T568A, the other is T568B. Only difference between the two standards is that the transmit and receive pairs are interchanged. So you can see that the orange and green are swapped between the two standards. So generally, the T568B standard is used in practice. But when you see signs of A and B on different connectors and patch panels in the future, remember, check it out. Do you need to be consistent with B or consistent with A? Now, if you're asking how the numbers from 1 to 8 are determined here, well, these numbers are the numbers from left to right when you hold the RJ45 connector with the underside of the RJ45 connector inserted into the end of the cable facing us. Contacts up, I like to say. Now, you are seeing a picture of an empty RJ45 connector that has not been attached to the cable end. This is a connector that has been affixed in accordance with the standards. So number 1 indicates the leftmost pin, and number 8 indicates the rightmost pin. So as you can see, the orange-white pin is at the far left. That is fastened according to the 2568B standard. So now let's take a look at the ends of a cable with both ends terminated. 1, orange-white, 2, orange, 3, green-white, blue, 5, blue-white, 6 green, 7 brown, white, and 8 brown. Hey, watch out for the green wire. You can see that the green pair is located on pins 3 and 6. And while the other cables are located next to each other, also note that in pairs, the first white cable comes first, then the main color cable, while the blue pair includes the first blue, then the blue-white. Flat cable, cross cable. All right, so the new generation might not ever know what a cross cable is because all devices produced today are automatically produced with a straight cross detection system, auto MDI or MDIX. Therefore, it's possible to make all kinds of connections using the flat cable pictured above. However, the standards are as follows. The Ethernet connection type on the ports of the user devices, like computers and routers and servers and stuff, is installed in accordance with T568B as its standard. So it means that I'm sending signals from pins 1 and 2, right? I'm transmitting, and I'm receiving signals from pins 3 and 6. You see that? Cool. So the device in front of me needs to receive the signal that's being sent through the receive pins, and then send the signal back through the transmit pins. Now, if I use a flat cable while transmitting from my pins 1 and 2, the signal that I send will reach the 1 and 2 transmit pins of the other device, or vice versa. So while I'm waiting for a signal from my pins 3 and 6, well, the other device is going to wait for a signal from pins 3 and 6, and the transmission is not going to take place. So in fact, the signal that I send from pins 1 and 2 should reach receiving pins 3 and 6 of the other device, or vice versa. The signal sent from pins 1 and 2 by the other party should reach my 3 and 6 receiving pins. You follow? So here, I'll need to produce a cable that will carry the signal that I send from my pins 1 and 2 to the 3 and 6 ports on the other side. That's why we call it the cross cable. So if we take a look at a cross cable, well, as you can see, the orange pairs located at pin 1 and 2 on the right end are transferred to the pinout on 3 and 6 on the left end. Likewise, the green pairs on pins 3 and 6 at the right end are also connected to pins 1 and 2 at the left end. So to show it in a different way, the ports on the switch devices are designed to be 1 and 2 receiving and 3 and 6 sending automatically. Therefore, you can directly connect a user device to the switch device. If you're going to connect the user device to another user device or connect two switches together, that's when you normally need to use a crossover cable. However, just as I mentioned, almost all systems now have the feature automatically detecting the exchange ports. They adjust themselves according to the status of the systems that they're connected to. Freaking genius, yeah? So, now let's take another look at both cable sequences. So here's some cable categories. Copper Ethernet cables are divided into different categories according to the amount of data that they can carry, depending on the development of technology. So the thickness of the copper wire used in the cable and technology used also will increase the amount of data carried over the cable. You'll see why here. There's good old Category 1, and it's mostly used for analog telephone lines. There's Category 2, an old technology, but the maximum data carrying capacity is 4 megabits per second. Category 3, well, they're still in use today, and they're used in 10BASE-T networks, but predominantly should be left in the past because they support only up to 10 megabits per second. Now we're getting into Category 4. Again, the old token is used in ring networks. Supports up to 16 megabits per second, but you see how we're increasing in speed? Category 5 supports up to 100 megabits per second. Then you step up to Category 5E, and that supports up to 1 gigabit per second. Category 6 is the currently widely used cable type, and it supports up to 1 gigabit per second. Now let's talk about shielded twisted pair, or STP. Now earlier we were talking about UTP. That is unshielded twisted pair cable. But there's also STP. So these are cables that are made of shielded twisted pairs, and they're used especially in data centers. So the characteristic of the shielded twisted pair, or STP, is that there's actual aluminum foil wrapped around the cable pairs. There's also the addition of a grounding wire. Well, thanks to this developed technology, the cable is protected from external magnetic effects and any other external interference. So the amount of data carried over the cable can be increased significantly. So it's thanks to these features, STP cables can carry data up to 10 gigabits per second. So an STP cable looks like this. The RJ45 connector used to terminate the STP cable is also designed in accordance with the shielded structure. And here's the connector and what it looks like. STP cable is a more expensive technology than UTP. In addition, connector termination to the cable end can only be done by using expert teams and equipment. UTP, on the other hand, is relatively cheaper and has a structure that can be terminated easily. So for this reason, STP cable is generally used in data center infrastructures that require high speed and reliability. The STP cabling standard used in data centers today is classified as Cat 6A or Cat 7. All right, so that's the lesson up to here. So we've now learned about these copper cables. I hope you learned a lot without getting too bored. Anyway, I want to see you in the next lesson.